Hello everyone, welcome back to my YouTube channel. So today we are going to discuss a machine learning project which is mobile classification. Okay, so in this project I have used three machine learning algorithms which is uh, decision tree classifier, KNN and logistic regression. Okay, so here we have imported NumPy, Pandas, SNS and Matplotlib. Pilot has PLT. So Seaborn and Matplotlib we are using for data visualizations, and NumPy and Pandas are used for data analysis and working with numerical values, as it makes easy to apply mathematical functions. So let me explain you the data fields. So here this is the price range which is our main parameter. So here 0 means low cost, 1 is medium cost, 2 is high cost and 3 is very high cost. The data fields are battery power, Bluetooth, clock speed, dual SIM, uh, memory, mobile, weight of the mobile, pixel height, width, and etc. So here when we are gonna load the data, means we are gonna read the data. So here we are gonna deal with two data sets. One is the train data set and one is the test data set. Okay, so here we are reading the train data set, and data train dot head means it shows the first five rows of the column or first five rows of the data sets. And similarly, we are here reading the test data set, and here same head means we are reading the first five rows of the data set. Now data pre-processing. So data pre-processing a process of transforming the raw data into an understandable format. It is important step as we can't work with the raw data. So here the first data pre-processing we have done is a describe. So it describes the training data set like its mean, standard deviation, minimum, maximum, 25%, 50% and etc. And similarly we have described the test data set. Okay, so it describes the test data set like its mean, standard deviation, count, etc. Okay, now the shape. So here the shape method gives us the number of rows and columns in the data set. So data underscore test dot shape means it giving the number of rows and columns in the test data set. And similarly for data train dot shape means it giving us the number of rows and columns in the train data set. Now data test dot info. So we are using info to check if we have any none values or any missing values. Okay. So from this data we can see that we don't have any null or missing values. Suppose if we are having any null or missing values, it would have been less number, it means less than 1000, anything around 0 to 9989. And similarly we are checking for the train data also, whether is there is any outliers or not, or any missing values, unknown values are there or not in the data sets. So in train and test data set is completely fine. So let's begin with exploratory data analysis. So exploratory data analysis is an analysis approach that identifies the general patterns and the outliers in the data sets. So here we are mapping a heat map, okay, and heat map because so that we can see the relationship between the each columns in the data set. Okay, here the dark color tells us that the relationship is not good, whereas the light color shows us the relationship is very good. Okay, so from this I have plotted 4 to 5 bar graph. Okay, so first one is the relationship between the price range and the battery power. Okay, so the in x-axis so we have a price range, and in y-axis we have a battery power. Okay, so it shows that the mobile which belongs to the category 3 have good battery power as compared to others. This, now I am plotting the relationship between the price range and the RAM. Okay, same in x-axis we have a price range, and in y-axis we have a RAM. So again in this that it shows the mobiles that belong to the category 3 has the best RAM as compared to the others, 0, 1 and 2. Again let me tell you that 0 is a very low price range, 1 is medium, 2 is high and 3 is very high price range. Now here I am plotting the relationship between the price range and the 4G mobiles. Here again in x-axis I have my price range, and in y-axis I have my 4G mobiles. So it shows that the mobiles which belong to the category 3 have more 4G mobiles. Now I'm plotting the relationship between the price range and the 3G mobile. Okay, so same in x-axis I have my price range, and in the y-axis I have my 3G mobiles. So here the mobiles which belongs to the category true, which is a high, have a more 3G mobiles as compared to 4G, which is very good. Now, feature scaling. So in feature scaling, we are going to standardize the train data set and the test data set. So standardization is a data pre-processing technique which scales the data so that each feature has a mean is equals to 0 and median is equals to 1. Here, I'm from sklearn, I'm importing my standard scaler, and I've denoted standard scaler with std. Okay, x, I have denoted x is equals to data train drop price range, and access is equals to 1. Here, I have dropped the price range from the training data set because I don't want to scale the price range because price range is a main parameter, and I have given access is equals to 1, which means we are dropping from the column. If our access would have been 0, it means we are dropping from the row. Okay, so this is the data set after dropping a price range. So you can see that we have successfully dropped a price range from the train data set. Yeah, from the train data set. Now, we are checking the shape to just to ensure that whether we have dropped it or not. So it shows that 2000 rows and 20 columns. Before it was 2000 rows and 21 columns in the train data set. Now we are storing the price range in y variable. Okay, so y is storing the price range. So yeah, this is the price range which we have stored in y. We are dropping id from the test data set, and again here we have given access is equals to 1, which means we are dropping a column. Now here x underscore standard means x was my x when we dropped a price range, and standard std is a standard scaler. So fit transform x and data underscore dest is equals to transform data set. Here fit means it fits the data into the model. Okay, and transform means it's transforming the data into the form which is more suitable for the model. And the fit transform nothing but just the combination of fit and transform. Okay, so here we have just scaled our mean, which is ranging from 0 to 2. You can check 0, 1 and minus 1. Okay, yeah. And similarly for test data also we have we have standardized our test data. Now model training. So now we are gonna train our model. So we are gonna train a model using three machine learning algorithms, which is decision tree classifier, KNN, and logistic regression. Okay. So for model training, first we are gonna import train test split from sklearn.model selection. Okay. Here we are gonna split our data. Okay. X train, X test, Y train, Y test. Okay, we're splitting it into x, y, and test size 0.2, which means the 80% of data should be main and 20% should be rest. Another is a 20%. And we have given a random state equals to 1. Okay, here x train means training the data feature for the training set, and x test means training the data feature for the test set. Similarly, for y train means training the data labels for the training set, and y set test means training the data labels for the test set. Okay, so what here I have mentioned the data features and data labels. So what is exactly data features and data labels? So data feature is the characteristics of the data that is used to predict the target variable. So here a target variable is price range. To predict the target variable, which is a price range. Okay, yeah. The data labels the target variable that I'm trying to predict. Okay, yes. So now, after performing this, we have split our data successfully. So let's check the shape of each. So the shape of X train is 16,000 rows and 20 columns. And for X test dot shape is 400 rows and 20 columns. For Y train shape is 16,000 rows, and here is 400 rows. Now, our first machine learning algorithm. So we are using a decision tree classifier. What is decision tree classifier? Decision tree classifier. So decision tree classifier, it is a decision support tool that uses a tree-like model of decision. Okay, it works by splitting the data into smaller subsets, and it will predict the output based on a subset that the set of features falls. Okay, so we are just using DDC to get all the possible solution of the problem or decision based on the conditions. Okay, so from sklearn.tree we are importing our decision tree classifier. Okay, so decision tree we are denoting decision tree classifier as DTC. So DTC dot fit, again I said fit means fitting the data into a model. So if you're fitting the data into a model has X train and Y train. So X train is our data characteristics and Y train is the data labels, which is my targeted variable. Okay, so now here is the prediction that we received. Okay, so here the prediction is 0 0 1 0 3 2 1 1. So it shows the prediction of all X test. Okay, yeah, and we are comparing with the Y test. So Y test is a price range which we have stored. Okay, yeah, so let's predict. Okay, like see, the price range is 0 0 1 0. Here the price range is 0 0 1 1. Okay. Similarly, the for the last, let me see, the price range is 3310. So price range here is 3210. Okay. So let us check the decision tree classifier's accuracy score so that we can get a better idea. So we are importing accuracy score from sklearn.matrix. Okay, decision tree accuracy is equals to accuracy score of y test underscore ypred. So y test here in which I have stored my price range, and ypred is nothing but the prediction which I have just made using decision tree classifier. Okay, so it shows that our accuracy is 0.85. Okay, which is good, like which is literally it's very good accuracy. Okay, now so this was we got this accuracy of 0.85 using decision tree classifier. Now let's apply a second machine learning algorithm, which is KNN. So KNN, so it is used for classification and regression task. It relies on the idea that similar data points tends to have similar labels of values. It sorts the training data sets as references. Okay, yeah. So again, I have x train dot standard scalar is equals to standard dot fit transform x train. So again, I have to tell you what is fit transform. It is nothing but the combination of fit and transform. Okay, and transform I have explained you here before only. What's the meaning of the transform? Transforming a data into a form which is more suitable for the model. Yeah. Um, so yeah, I have transformed. I have done this also now. Now I have imported sk dot k neighbors classifier from sklearn neighbors dot sklearn dot neighbors, and kn is equals to I have denoted k neighbors classifier as knn. Now fit means fitting the data into a model. Okay, so I'm fitting my data into a model as x train standard and y train. So now I am predicting. So KNN dot predict x underscore test underscore standard. Okay. So here we got the prediction. Okay. So zeros 1 1 0 1 0 0 1 till 2 3 2 1. Okay. This is the prediction. Now we're comparing this prediction with our price range, which we have already stored in white test. Okay. So let's check the price range. What is your zero? Let's compare the price range of the price range which we have stored and the price range which we have predicted now. The first force was a 0 0 1 0 1. Okay, 0 0 1 0 1. Let's see here, it's 0 0 1 1. Okay, let's check the last one. It's 2 3 2 1. It's 3 3 1 0. Okay, so to get a better picture of the KNN, let us see the accuracy score of the KNN. So again, KNN accuracy is equals to ypred and ytest. Ypred, nothing the predicted values which we have just predicted, and ytest means the price range which we have already stored. So after doing it, we got the accuracy of 0.52. So like, which is not at all good. Okay, we can't uh, give this model or deploy this model in the market. Has its accuracy is zero point 0.5, which is very, very, very less. Now, I have now performed a decision tree classifier and a KNN. Now it's time to use a logistic regression algorithm, which is a third machine learning algorithm. So what is logistic regression? It is a type of statistical model used for classification and prediction analysis. It estimates the probability of an event occurring. Okay, like for example, let me say whether a person he has voted or not voted. So it's a probability. It might be true that he has voted, or there is a case that he might have not voted. Okay, so yeah, so it depends. It is based on the data sets of the independent variables. Okay, this is what a logistic regression is. So now, uh, again, I have importing my logistic regression from sklearn.linear model, and I have stored logistic regression as LR. Now I'm fitting my X-train standard and Y-train. Okay, so fit means we are standardizing our data. Now I'm predicting my test underscore standard. Okay, so here the prediction shows me 00112. 00112. Oh, it's very good. Like, it's exactly the same. In last one it is 3310, and here also it is 3310. Like, this model is performing perfectly fine. So let's check its accuracy score. So we know whether it's really a better model as compared to decision tree classifier and KNN or not. Okay. So I am checking the accuracy here. So your Y-pred is nothing but a prediction which I have just made, and Y-test is the price range which I have stored. Okay, so here we got the accuracy of 0.96, which is very good. Like, it has performed best among the other two algorithms. Okay, like the first algorithm, it gave us an accuracy of something 0.85. KNN gave us the accuracy of 0.5, and logistic regression gave us an accuracy of 0.96. Like, this model, mobile classification using logistic regression. So this model we can deploy in the market. Now, so to get a better picture, now we are going to plot a graph between the accuracy of the algorithms to determine which model is working perfectly fine. So here I'm gonna plot a bar graph. Okay, in x-axis I have given my name of the algorithms, which is decision tree classifier, KNN, and logistic regressions. And heights I have given as decision tree dot accuracy, KNN's accuracy, and logistic regressions accuracy. Now, in X label, I have given as algorithms, like this is my X label, which is an algorithms, and in Y label, I have given my accuracy score. Okay, and then I have written the plot dot. Now, this is the graph which we have got. Okay, so this graph shows that our logistic regression model has performed absolutely best with an accuracy score of 0.95, and our KNN model is performing worst because its accuracy score is just 0.5. Okay, like it's of no use. Okay, now, the final result is that after doing all the exploratory data analysis, data loading, data wrangling, and testing my model using decision tree classifier, KNN, logistic regression, I came to know that using logistic regression, a model is performing better and have accuracy percentage more than 95%. So this was all about mobile classification project, in which I have used three machine learning algorithms. I have trained my data. I have used standard scale feature scaling, which standardizing my data. I have plotted different bar graphs and many things. Okay, so I hope you like this video. Do like, share, and subscribe. Thank you.